Today's video will talk about how to form and break epoxide rings. To open a ring, there are two options. Option one, use a strong acid, and that will make a carbocation with which some sort of nucleophile will attack at that carbocation, whether that be the anion of the acid or maybe the lone pair of a solvent. Option two is to just use a nucleophile such as hydroxyl to do a SN2 reaction at the less hindered or less substituted carbon. So let's try these examples. In this first one, let's do it with an acid. So the acid is going to form a carbocation at the more stable, more substituted position. And then the nucleophile, usually it would just be the anion of the acid. But because we have a solvent that is not water, we're going to have MEO attack at this position, which will split this bond. Therefore, we're going to redraw this picture again, but we're going to split this bond. Okay, so when you're drawing, I would advise you to draw the carbons first. It's really easy to forget one of these carbons. Okay, so this bond is split. So on our carbon 2, we already have two methyls and a carbocation. And on the other side, we have an O anion, okay? Now this carbocation is going to get attacked by some sort of nucleophile. In this case, it's going to be the solvent. If you have water solvent, you will just get OH, but we have methanol solvent. And this O is going to get protonated, so that will be our hydroxyl. So this will be your first drawing. If you're reacting this picture with a base, you're going to get an SN2 reaction, an attack at the less hindered, less substituted carbon position. So that will be this spot, all right? So this bond's gonna break. So let's redraw the thing. Okay, so on our carbon 1, we have our OMe, our nucleophile. And on carbon 2, we have two methyls, as well as the one bearing the O minus, which gets protonated. So that will be our product with a base. Now, it could be a base, it could be a nucleophile, same thing. And if this were water, you would get OH instead of MEO. So that's how you would open a ring. Use a nucleophile for SN2 or use a strong acid for a carbocation. Same thing if you have this type of ring, which is made from alkenes, but there's pretty much no difference except you want to note that when you open the ring, you will have branches. So you're going to have a wedge and a dash. Okay, because this is in acid, we're going to get two hydroxyls. Okay, let's use a nucleophile this time. A nucleophile is going to be one of your branches, and the alcohol will be the other one. Okay, and the alcohol came from the original oxygen within the epoxide. So note that this is anti, wedge, and dash. Now let's learn how to make rings. If you're starting with an alkane, there will be an SN2 reaction that is intramolecular. That means the chain reacts within itself. And you would use some sort of base, which oftentimes is hydroxyl. So the hydroxyl will react with the alcohol, the hydrogen on the alcohol. So this will break off, therefore giving oxygen a negative charge that will want to attack the carbon within itself that bears the leaving group, and therefore you will have a ring. Now, be really careful when you draw a ring. There are 4 carbons, so I'm going to draw oxygen and 4 carbons. Connect the dots so you don't miss out on any. Then check if there are any methyl branches. Nope. So then this will be your product. That's how you make an epoxide ring from alkanes, SN2. If you want to make a ring from alkenes, it's even easier. You would just use MCBPA unconditionally. Now, how you would draw this is you would draw out the carbons that bear your alkene. Okay, connect the dots. Now, instead of drawing an additional line as an alkene, you're not gonna form the epoxide. So there's your epoxide, and there are methyl branches that you're gonna express as cis in this case. Okay, then this is because we've done two wedges. This is cis because our reactant was in Z configuration. So when you're making a ring, making an epoxide ring with an alkene, you use MCBPA unconditionally, and you retain the configuration. Okay. Whereas if you want to open a ring that was made from an alkene, you will use an anti-product. That means a wedge and a dash. So to recap everything, open any type of ring, you can use an acid for carbocation at the more hindered, more substituted position, more stable position, or you can use a nucleophile, SN2, at the less substituted carbon. Whereas if you want to make a ring, you would use SN2 for alkanes with intramolecular reaction, or for alkenes, use MCBPA while maintaining the configuration. And I hope this video was helpful. If it is, make sure to hit a like and subscribe.